So welcome all for week 10 of Learning Analytics and Tools course. So we'll begin today's session by having a short recap of what was covered in this week's lectures. So this week's topic was NLP or Natural Language Processing. So yeah. So NLP or natural language processing. So we have all heard these words of large language model, which is also one of the application of NLP or natural language processing. So since now ChatGPT has proved that NLP can percolate to every aspect of our life. So similarly, even in learning analytics, NLP had percolated before ChatGPT was, or the NLP or the large language models were actively part of our day-to-day lives. So before that, we have been using the natural language processing to our advantage as learning data scientist or people or researcher who are dealing with um, learning, improving students' learning outcomes and so on. But before that, let us have a brief overview or brief idea about what exactly is natural language processing. So, as you break down the word natural language processing, natural language is the way we speak language. So, computer languages are different, the programming languages are different, and what we speak is different. So, by natural language process, by natural language, we mean the English which we are speaking, or any language which we talk for conversation purposes. So algorithm used to process the natural language so that computer can understand what is being spoken. So the translation of our English into computer's language is natural language processing. So for what purpose it is used? To automate certain things which are time consuming, where computer can help. If computer understands the language being spoken, what is being said, if computer understands that, then computer can help in making our tasks faster. So in what sense NLP will be useful is information extraction. So all of you would have noticed that when we open our Amazon, when we go to see the reviews, there is a short AI generated summary which will go through all the reviews and which will extract the relevant information about the product quality, whether the product was returned by the customers, and all that information is extracted and summarized in understandable format, interpretable format, and that is part of our review, which is AI generated review. So similarly, when we want to extract certain information out of large articles or large research papers, so there are some NLP tools or artificial intelligence tools which help in summarizing the research papers, the long research papers, which are sometimes 20 page long or 60 page long or 100 pages long. So to summarize the textbooks, so all that is done using NLP. Now in teaching learning context, we can create question and answer database using NLP techniques. When we give the textbook and ask ChatGPT, so when we give some chapter to ChatGPT and ask him to generate the questions and their model answers, ChatGPT will be able to generate that for us. Then translation from one language to other language is also a task for natural language processing. Then having the chatbots or the personal assistants which will guide you or which will answer your queries, so all that is backed up by natural language processing. Then speech to text, there are many softwares which convert the speech data to textual data in real time, so they are also based on NLP. Then social media analysis or sentiment analysis of the post. So if somebody posts some hate message or hate post is posted by online on social media, that account gets automatically blocked. So all this is part of sentiment analysis. Majorly for review purposes, sentiment analysis is used, and for social media analysis also, what people are posting on social media, whether it is following the guidelines, whether they are not engaging into hate speech. So all that thing, for monitoring all those points, the NLP is actively used. Then sentence completion, when we type messages in our smartphones, based on what word we are typing, the next word comes. So that is for sentence completion. That algorithm is also based on NLP principles. So so now we will come to techniques which are used, or the functions which are part of NLP, which will help in understanding or converting English into a computer understandable language. So two such ways to do that are lemmatization and stemming. So lemmatization is grouping the inflected forms of word. That means all the forms of verb to be grouped as the stem word, or as the root word, not stem word. So similarly, talking, talk, talks, talk, all this will be reduced to the root verb, which is talk. Yeah. And similarly, in stemming, what will happen is all the same set of rules are applied to form the word from which all the other words have stemmed. So that means, say, eating will become eat, talked will become talk, and so on. Yeah. So what happens is we are just removing the suffixes in stemming, but in lemmatization we are going a step ahead and converting um, every word to its root word. Whatever word we are encountering, we are converting that to root word. But in stemming, we are just going to the word from which it has stemmed. We are just trimming that particular word to get to the root word. Now the concept of n-grams is, uh, I, so unigram is a group. So n-gram concept is grouping the words in the sentence which are coming together, right? So unigram is one word group. Bigram, as the name suggests, is the group made up of just two words which are adjacent to each other. Then similarly, trigrams are three adjacent words, and n-grams is n such adjacent words grouped together. So why we need to group these words together? Because many of the times these group of words, they will occur frequently in any text or textual data. So one such assumption we have: this probability of the current word depends on the probability of the word which has previously occurred, the word which has occurred just before the current word. Okay. So that's why we do this grouping of one word or two words together, three words together, four words together, to deduce the probability that what are the chances that all these words will occur together. Yeah. So this will be more clear when we solve the problems. There are problems based on this very simple probability calculations. Now coming to another concept of minimum edit distance. So this is how computer interprets the English language by so computer speaks the language of mathematics. So everything we talk, so computer will convert the entire natural language the natural language based paragraph or chapters or whatever text it has into a probability. It will interpret as, okay, these 2-3 sets of words, they will always occur together. So if one word occurs, these two words are also bound to occur after that particular word. So that's why we have to understand this concept of n-gram. Now then, minimum edit distance. So this is very simple, that there are words which are similar to each other. They are very close, the spelling of the words are very closed. So in that case, even if the spellings are not closed, we will not write everything again. The computer will not understand every word from every alphabet to alphabet. What they will do is, they will insert, delete and substitute. They will apply these three operations to generate new word based on the old word. So this way, similar sounding, or the words which have spelling very similar to each others, are identified. What is the minimum edit distance? So what is edit distance is how many alphabets in that word we need to replace so that the new word is generated. And so in order to generate new words, how many alphabets we need to replace from the older word is the edit distance. Now bag of word is another concept, that is how these sentences are parsed, sparsed. So every word frequency is calculated, the sentence structure is decided based on this sparse vector. So these are the sparse vectors. So what happens in this bag of words is, when we have multiple sentences, no? Yeah, so Shrija, Markov assumption is assuming that I explained that we are grouping two words or three words together, and we are deducing the probability that what is the probability that one of the word occurs, then what is the probability that rest of the words will occur together. So it is also explained in the lecture, and here also I have included what is Markov assumption. So we are assuming that probability of current word depends on the word which has previously occurred. So now coming to bag of words, what we do is, when we have multiple sentences, some words may be repeating. So what we will do is, we will note down all the distinct words which are occurring in that group of sentences, right? So this is the bag of the word for this sentence 1 and sentence 2. So we have these two sentences. First sentence is, students interact with peers in class, and second sentence is, peer instruction increases students' interest. Yeah. So we will write the word count. So word students has occurred twice, once here and once here. Interact has occurred only once over here. Then with, only once over here. Peer, here is peers and here is peers, so has occurred twice. In is here once. Class just once here. And so we listed down all the words and how many times each word has occurred. So now we are going to index. Yes, computer will interpret peer and peers as the same because of lemmatization and stemming. So if peers is converted to peer, which operation it is, lemmatization or stemming? So in lemmatization, word is reduced to its root word, but in stemming, these suffixes are removed. Okay, so this operation will be stemming. So similarly, students and the students with apostrophe, that will also be interpreted as same word. So yes, by computer it will be interpreted as same word, because computer will do this stemming and lemmatization. So based on that, both the words are same. So interacted and interacting, if the sentence would be, students interacted with the peers in the class, and now students are interacting with the teacher in the class. So in that way, interacted and interacting will also be lemmatized to interact, and that will be interpreted as the same word. Yeah, so they will be interpreted by computer as the same word, because computer will perform stemming and lemmatization on it. So that's why peers and peer are the same word for computer. So this is how we will make list of all the base words or the root words which are part of the sentences, and how many times each word has occurred. And now what we will do is, we will assign index. We will index these words. So that means we will list down these words. So first word is student, second word is interact, third word is with, fourth peer, 5 class, 6 instruction, 7 increases, and 8 interest. So now we have this index associated with every word. So now sentence and index is the sequence in which we have made the list or bag of the words. We have bagged all the words together. Now based on this, how we will form the sentence word? So in first sentence, the first word has occurred. So that means we will convert this. First word is here students. Then second word interact. Then third word with. Fourth peer. And fifth class. So this is how sentence 1 is interpreted by the computer. Students interact with peer, class. So now if you convert every word after performing after performing lemmatization and stemming, this will be reduced to this sentence only. Yeah, students or student interact with peer in class. Yeah, so same way we are not, so same way it has happened here. So here also you can make, first is student, then the second word in this list is absent, which is interact is not there, with is not there, then peer is there, then class is not there, then instruction increases interest is there. Yeah. So even though the order was peer instruction increases interest, but since we are referring to a bag, we are just here noting down, the sparse vector notes down out of this bag which word was present and which word was absent. So when we say 1, that means that particular word is present. When we say 0, from the list of bag of the word, that particular word is absent. So I'm explaining what is sparse vector. It is the list of which words out of the bag of words which are present in sentence. So if the word is present, then it will be denoted by 1. If word is absent, then it will be 0. So sparsing is the processing of the sentence, or how that sentence will be interpreted or stored by a computer. So sparse vector will denote which words out of all the list of the words which we have, which words are present in that particular sentence. Now this is index. So now this is not in correct order. So we should also have correct order of these words. Right? So we have this, we assigned index here. 1 was to, second was interact, third was with, 4 was peer, 5 was class. So what we will do is we will now write down the sequence of those indices to get the correct structure of the word. So from this we know which words are present, from this we know the order of the words. So these two together, word frequency, this is word frequency, and this is the sequence in which we can arrange these words to get the meaningful sentence. So together they are considered as sparse vector. They will help in sparsing the information or interpreting the information and reproducing the information by a computer. So word frequency together with this indexing is important to reproduce this structure. Yeah. So this was about the sparse vector. Even though the name sounds fancy, it is just counting the frequency, counting how many words are happening in what sequence it is happening. Okay, so now in in education domain or in learning analytics domain, we can use NLP for adaptation or personalization based on text. We can have the assessments, we can have the NLP based assessments, and based on their assessment we can have adaptation for each student based on the answer which they have given. We can identify the misconceptions from their answers using NLP tools. Then report generation can be done, the summarization of our assessment or our analysis can be done using NLP. Of course, plagiarism, if that particular text is copied, we can match it against the text which is already available. So for plagiarism we can use NLP. Then information extraction for education, I think we discussed this information extraction, that nowadays there are many tools which will summarize the research paper for you, will summarize the PDF which you are feeding it to it. So all that is information extraction. We will extract all the important information. So plagiarism is copying. So when you are copying textual information for your assignments or for your reports, for anything, if you are copying somebody else's text as it is, that is considered plagiarism from other sources without proper citation or without acknowledging that this particular text was not yours. We cannot detect body posture from NLP because, as the name suggests, it just deals with the language, this thing, but whereas NLP is part of computer vision. Yeah. So it is also part of one of first question. Since now we are, can we detect the body posture from it, was the question asked in the chat. So question is, which of the following is not the application of NLP? So extraction of information from body posture, that if the body posture is like this, then am I interested, or if I'm yawning, then am I interested or excited, or if I'm frowning, then what will be my what information will my body posture will be, or if I'm sitting like this, or if I'm sitting upright, then what information is conveyed. That all will be involving processing of the video data. So that will be part of computer vision. That will be part of multimodal data analytics, where we will be thinking beyond using log data to know more about learning processes of learners. So this is not the function of NLP. Then automatic sentence completion is the function of NLP. Information extraction from the paragraph can be done using NLP. Summarization can be done using NLP. Summarizing 5 different actions done by students, by learners while learning, is not part of NLP, or is not, we cannot do this by NLP, because for this we need to process the log data. So this cannot be done by NLP. Then inferring sentiment from social media post is, of course, comes under scope of NLP. So since the question asked is not, the correct answer is option 1 and option 5. Okay, moving on to second sentence. So let me tell you that this week's content is very easy, because you just have to understand the theory and very, very simple problems. So this is also one of the scoring weeks out of 12 weeks. So try to understand how this probability is calculated. Then some of the questions, similar questions, will come in the final exam. So please, the probability calculation is very simple. So try to do it. So here we have to calculate the probability of to and went. So this is based on the Markov assumption, which we saw, that probability of current is based on, or is influenced by the previous word. So that is how we will calculate the probability of, what is the probability of the word, what is the probability of occurring of the word to compared to went. So what we will do, we will see how many times this went has occurred. Yeah? How many times went has occurred? 1, went 2, and 3. So went has occurred 3 times, and how many times went 2 has occurred or 2 has occurred? So went 2 or 2 has occurred once and twice. Yeah. So very simple to calculate. This is 2 by 3. Option number 2. Right? No confusion, nothing. We just have to translate it into frequency. What is the frequency of went? What is the frequency of to and went together? Now, edit distance is how many alphabets you need to change in order to convert one word into another word. So what they have asked is edit distance between intention and intuition. So what I'm going to do is, I'm going to write this one above the other. Intention and intuition. So these 3 letters are going to remain same, and last 4 letters are going to remain same. So how many letters we need to replace, like insert, delete, all those operations, how many times we'll have to do is twice. So the answer is 2. Yeah, please check the slide 2. Done, Shrija. We just calculated the frequency and computed the probability of the words to and went to get the answer. That's it. Very simple to do. So okay. So we changed only 2 alphabets or 2 letters from intention to change it to intuition. So the edit distance, the minimum edit distance between intention and intuition was 2. So question 3 done. Question 4, select the correct set of operations which are required to calculate minimum edit distance between two words. So how many times we'll have to do the operations on alphabet? Which type of operations we need to do? Insert, delete and substitute. Insert or delete or substitute. So if we are to perform these three operations, how many times we have to perform these three operations will help us in determining minimum edit distance. Shrija, we can't do this either. What we can do is we can come back to it, repeat everything together, but you need to keep up with speed of rest of the class, Shrija. Otherwise what happens is it will break the flow. So what I did here was I saw that these three letters need not be changed and the last four letters are same in both the words. Only letters or alphabets which need to change are these two. So that's why minimum edit distance was 2 between intention and intuition. Okay. Now here, this is the theory part. How many times we have to perform insert, delete and substitute operation? That will tell us minimum edit distance. So this was the part of theory about minimum edit distance. So insert, delete and substitute are the correct answer. Because in minimum edit distance, when we want to convert one word to another, we are not reading that word. We are not creating anything new. We are substituting, either substituting, inserting or deleting. So correct answer is option 3. Now question 5. Which of the following is a tool for NLP applications developed by team at Stanford University? So this is also one of the scoring question. If you have gone through the lectures, then you will be able to answer this question. In lectures, this tool has been shown. So that's why watching the videos is important. Okay, so before you go for your exam, please watch all the videos. Yes, answer is correct. Core NLP is the name of the tool which was developed by the team at Stanford University. So there is nothing informative in this. It was just part of the lecture that once sir shown the URL and given a short demo of this tool. So that's why the question has been asked here. A simple recall type question. If you have gone through the video, then you will be able to answer such questions. Question 6. Following pairs of words are stemmed to the same form by Porter's stemmer. So Porter's stemmer is a stemming algorithm. It's just a fancy name given to. So what we will consider is, we will consider it as stemming. So following pair of words are stemmed. A stemming function has been performed on these words. So which of the following pairs you would argue that shouldn't be combined or compared by stemming? So what stemming does is, stemming will remove the suffixes and trying to get to the stem word from which the other words are stemming. So in abandon and abandonment, if we remove the ment, the suffix from abandonment, can we get the word abandon? Yes. So this is stemming. Again, marketing will come to the option number 2 and option number 4 at the end. I will first let's get clear on option 1, 3 and 5. Okay, marketing and markets. So if we remove the suffix, markets become market, and marketing, the ing will be removed, will also become market. So this will be market. So stemming is being performed here. Now volume and volumes. If we remove this S, this is volume. So the word from which it is stemmed is volume. So everybody agrees with me that option 1, 3 and 5 with stemming it gives the same word. Anyone has any doubt here? This is abandon, this is market, and this is volume. Are we there? Okay, great. So now let's check option number 2, absorbency and absorbent. Okay, so even though by first look at both the words, they don't seem to be stemmed for the same base word, but the rule of stemming is we will remove the suffix, we will remove the alphabets at the end of the word. So if we remove E and T, what is the word we are left with? Absorb. And if we remove the word E and CY, what is the word we are left with? Absorb. So can absorbency and absorbent be reduced to same word? Can they be grouped or combined using the same word? Right? Now if we try to Ria, see, stemming is nothing but removing suffixes. So suffixes are the letters which are put at the end of the word. So here in abandon and abandonment, this meant we removed, MENT. In marketing and markets, we removed one letter S from here, ING from here. In volumes and volume, this one S removed, so it is reduced to one word volume. Similarly, if we remove few letters from absorbency and absorbent, letters from the end of the word, towards the end, suffixes towards the end. So towards the end, E and CY if we remove, and E and T if we remove, it will give us the one word only, na? Absorb. Both the words can be reduced to one word, which is absorb. Right? So that is what stemming is. We will remove the letters at the end, we will remove the alphabets at the end, we will remove the suffix and check if the word can be reduced to the same word or not. So absorbency and absorbent can be reduced to same word, which is absorb. Now can you tell me if university and universe can be reduced to same word? No, because if we remove S, it is meaningless. There is no such word with this spelling. And if we remove word ITY, we are getting this same spelling word, but it doesn't have any meaning, right? Universe's spelling has E at the end, whereas if we remove ISD, it will not be reduced to universe. So that's why these two words cannot be combined using stemming. Okay, so the correct answer is only option 4. Clear now for everybody? Is this clear? We will just try to remove the suffixes, the alphabets at the end, and we will check if we can deduce meaningful word based on those. So in university and universe, what was happening, that word which was getting deduced was not meaningful. Okay, that's why this is the correct answer, that we can't combine universe and university. Okay, I'm moving ahead to next question. Which of the below word can be obtained by minimum edits if the operation has cost 1 from the word affect? So minimum edit is 1. Okay, it should be 1. So we will check if only one alphabet is changed, then which word we are getting. That's the correct answer, effect. So yeah, everyone's with me. Option 1 is the correct answer. Right? We are changing just A with E. Rest of the alphabets are same. So this is the correct answer. Now this is the bag of the words problem. So now this is our bag of words. there is index associated with every word. So sun is 1, moon is 2. So this is not frequency, this is the index, the serial number which we have assigned to every word. So now which of the following we are given the sparse vector? Now we are supposed to construct a sentence using this. Very simple. Which number has which word has letter 1? Sun. Number 9, sets. Number 12, in. 11, the. And fourth is. This is what we are supposed to do. Now what is the correct answer? Sun sets in the east. Option number 4. Understood how to interpret this? So if you are to ask convert this into a sparse vector or a sequence in which you are supposed to align, then how you would do it? So we will come up with 2. Like there are 12 words in our bag of the words. Okay, so first word is present, so 1. Second word, moon, is absent in this sentence. Sun sets in the east, so it will be 0. Third is stars, which is absent, so 0. Fourth is east, which is present, so 1. Then fifth is west, absent, so 0. Sixth is north, which is absent, so 0. South is absent, 7th word, so 0. Eighth is rises, which is absent, so 0. Sets, 9th word, which is present, so here it will be 1. And the 10th word and is absent, so 0. 11th word the is present, so 1. And word in is also present, so 1. And now the sequence is here: 1, 9, 12, 11 and 4. Yeah, so this is how we will come up with sparse vector for this particular example. So now it is clear which word from bag of the word is present in our sentence and in which sequence it is present. That information is important. So I am moving to next question.
Ma'am, shall I hear it again, ma'am? Can you explain again?
Sure. So what bag of word is? Bag of word is collection when we have some text data with us, like multiple sentences. Then what are different distinct words which are part of those multiple sentences? Some words may be repeated, so we will not write them down multiple number of times. We will write every word just once and make a list of the words which are occurring. So this list of the words will be happening after the lemmatization and stemming. We are reducing it to root words and we are noting down all the root words. So now this is bag of the word. This is bag of words. We are listed. We have assigned an index or number to every word. 1, 2, 3, 4, 5, 6. So there are 12 words. There would be multiple sentences. But now we are supposed to make a sentence based on this index. 1, 9, 12, 11, 4. So this is the sequence in which words from this bag of words are supposed to occur in the sentence. So first word is sun, ninth word is sets, and so on. So we formed this particular sentence. But now if we are supposed to come up with a sparse vector for this sentence, then we have this 12 words in our bag of words. So out of these 12 words, which word is present in the sentence? So there are 12 entries in this list. Whatever word was present from this sequence 1, 2, 3, 4. So first word was present, so I wrote 1. Second word moon was absent, so 0. Third word stars was absent, so 0. East was present, so 1. The next word is west, absent 0. North, absent 0. South, absent 0. Rises was absent, so 0. Now sets is part of this sentence. It is present in the sentence. So here we have written 1. Now again 10th word is and, which is not present in the sentence, so 0. And the and in, 11th and 12th word are present, so 1, 1. and this is the sequence. So this is how we
Okay.
will interpret this sentence using bag of words. So this
Okay,
is the
okay.
present or absent, each word is present or absent, and this is the sequence in which.
Okay.
Okay.
Thank you. Thank
Yeah.
you.
So is this clear for everyone? Shrija, are you okay with this now? You got this? You had confusion when we were going through in that theory. If you also want to ask some questions, I'll give you some time to type in the chat box and you can ask. Okay. Since now only 2 questions are remaining, so what I'll do is we can come back to your doubts at the end. Okay, so I'll do the question 9 and 10 and then we'll come back. So this is also which of the following techniques will be using for the purpose of converting keyword into their base form. There could be multiple answers right to this question. I'm getting only one option as correct answer in the chat box. So I'm giving you hint that there could be multiple answers correct. Yes, now I'm getting correct answers. So lemmatization and stemming, option number 1 and option number 3. So we saw lemmatization and stemming multiple number of times. We saw how it is converted into their base form. So now question 10 is statement 1 is Ram loves to watch movies, and statement 2 is Dev loves to watch cricket matches. Now what will be length of document vector? Now what is document vector? So based on bag of words, we wrote this, no? Present absent. This was document vector. Okay. In other words, this is bag of words only. What will be, how many words will be part of bag of words is the question. What will be the length of document vector? What does it mean that how many words will be part of the bag of vectors? So first word Ram, second loves, third two, fourth watch, fifth movies, sixth word Dev, seventh loves is already done, so we will not be repeating it. 2 is already done, will not be repeating it. Watch is already done, we will not be repeating it. So cricket not yet done, so we will write it cricket. And 8th is match or matches. So total length will be 8. So now for statement 1, what will be the document vector? Ram 1 present, loves present, so 1, 2 present, 3, watch is 4th present, movies 5th present. Now 6th, 7th, 8th is absent, so 0, 0, 0, and we will be writing the sequence 1, 2, 3, 4 and 5. Now similarly statement 2, what we will do is Ram is absent, loves is present, 2 is present, watch is present, movies is absent, so Dev is present 6th, and cricket matches is present, so 1, 1. Yeah, and sequence would be 6, 2, 3, 4, 7 and 8. Yeah, so this is how we will be converting into sparsing vector, the document vector and the sequence. Okay, so this assigning 0 and 1, coming up with this is clear to everyone? Great. So we are actually done here with the assignment 10 of last year. So one message I wanted to convey was since couple of you requested a revision session, so revision session will be happening on 22nd October. So we are on week 10 content now. on 1st of October. On 58th and 15th, we will be doing week 11 and week 12. And on 22nd of October, which will be 13th week, we will be doing one revision session for a couple of hours from 7 to 8:30, 9, whatever the time permits. Okay, so October 10, October 22 will be revision of all the weeks. So I'll be giving you a list of all the formulae to keep in mind. If you have any doubts, if you're not able to solve any questions from current assignment, make sure to collate them and have a list. Sorry, just the term. Can you please that what is 1 1 and 1 2? Okay, so this together is called sparse vector. So this is index vector and this is the document vector. This together is sparse vector. So depending on your options, what options you have, depending on that you decide which will be part of sparse vectors. If the question asks sparse vectors, you will be given some options, no? So if option says 1100, that list present or absent wala list, so do this. If that has sequence, then follow this. Don't get confused, it is simple. You just have to be little smarter, understand and interpret the options, and then decide what to do. So now here, even though we did not know what is document vector, they are just asking some length, and looking at options, all of you answered correctly. If you go back to the chat box, you will see all of you have answered option 4, option A, that number 8 and option 4. So that means you just interpreted the options, and then even though you don't know the words, you do the cross solving. Look at the options and then try to understand what they mean by document vector. So all of you did this very correctly, very nicely. So don't get scared. These are all simple type of questions, like very simple questions, nothing complicated. You're not asked to code for anything. You're not supposed to write code for anything. You're just supposed to write answers based on what you have heard in the lectures and type of questions you have solved in assignment. So if our exam will be out of 50, then how much we have to get to receive certificate? That is as per this thing only, NPTEL rule, whatever the rule says. I did not understand this 30-75 rule. So you need to score 75%. So 75% of 50, which will be around 37.5. And you need to have some base performance in assignments, if I'm not wrong. And don't worry about the exam questions, because exam questions, many of the questions will be very similar to what we are solving and what you have already solved in your assignment, current assignment. So this is last year's assignment what we are solving. So in final exam, most of the questions will be very similar in nature, very minor changes in the numericals. Some theory questions may come as it is as well, because in theory you can't make minor changes, right? Questions like this you can make change. You can change the sentences and ask again what will be length of document vector for a different set of sentences. So if you understood the concept behind document vector, then you will be able to ask us. Yeah, for 17 you may not be able to, because I said 37.5 would be the benchmark for getting the certificate. So yeah, weightage is 25% of assignment and 75% of, I think 25 or 30% for assignment. I'm not sure what is current rule, but 75% for final exam is the rule. So and good thing about final exam is whatever number of questions, only 4 questions will be of very new nature. Rest of the questions will be of very similar to what we are solving. Minor changes in the question. Yeah, so again I have gotten this doubt that I need to explain this 1100 1100. So this 1 comma 1 comma 1 comma 1 comma 000 is nothing, but we had made this bag of words for this sentence, for these sentences, statement 1 and statement 2. We made a list, and what we did was we saw if first word in the list is present in statement word, yes it is present, Ram. Then loves is present, so 1 comma 1. Second word, third word, 2 is present, so 1. Fourth word, watch, is present, so 1. And fifth word is movies, which is present, so this one. Word number 6, 7, 8 was absent, so we wrote 0 comma 0 comma 0. Similarly, for statement 2, whatever word in this list, which number was present, we have assigned, written 1 for that number, like word 2, loves. Word number 3, 2 was present. Word number 4, watch, was present. But word number 1, Ram, was absent, so 0. And word number 5, movies, was absent, so 0. Sixth word is Dev, which is present in statement 2, so 1. Then cricket matches, word number 7 and 8 are present in statement 2, so this one and this one. If it is present or absent, so if it is absent we will write 0, if it is present we will write 1. So it is the present or absent list. In this sequence, which index is present, we will write 1 in front, 1 in that position. Which index is absent, we will write 0 in that position. Index is this sequence number in the bag of words, the list of bag of words. Whatever number, serial number you are assigning, that we will maintain. So serial number 1 word was Ram, which was present in statement 1. So in that position we wrote 1, and so on. So present or absent. This I told Shrija just now. I explained this 110011. This only I explained. If it is present, we will write 1. If it is absent, we will write 0. Based on this bag of words, we will assign sequence number to each word. In that sequence, if that particular word is present in the sentence, we will write 1. If that particular word is absent, we will write 0 in this list. So there are 8 base words or 8 words in our bag of words. That's why this length is 8. We have 8 terms. So first word was present, so we wrote 1, 1, 1, 1. Last 3 words are absent in statement 1, so we wrote 0, 0, 0. Similarly, in statement 2, first word was absent, so we wrote 0. The next 3 words, loved, to, watch, were present, so 1, 1, 1. Fifth word, movies, was absent, so 0. Sixth word, Dev, was present, so 1. Cricket matches, word number 7 and word number 8 was present, so 1, 1, 1. So that is how we came up with this. Yes, index can be assigned in any way. This list, this sequence number could be any way, but we have to maintain this 1 and 0 that correspond, for corresponding word only we are writing this. So in statement 2, the sequence was Dev loves to watch, but here in our list Dev is at number 6. So that number, that serial number could be anything. So sentence 2 can go first, then sentence 1 can happen. So we are free to assign this sequence number to our bag of words in any way. There is no any rule to assign this sequence number to bag of words. So this is for Shrija also, that this sequence could be anything. It is just random, in bag we just put things. So in this bag we are just putting all the words. So these words can have any sequence number in any sequence. But this 1010 is just if that particular word is present or not. If it is present, then 1. If it is absent, then 0. So sparse vector is combination or consist of whether the word is present or absent and then the sequence. So only this sequence will also give us information about whether the word is present or absent, right? So many of the times when we say sparse vector, many of the times only this sequence is expected. So in this sequence also, this number corresponds to the position in which we have wrote that particular word in our bag of words. So this is not fixed. The sequence in which we are listing down the words in our bag of words is not fixed. But then in a sentence, their sequence is fixed, their position is fixed. So this so that is why even if you don't write this will give us information about which word is present and in what position it is present out of all the words which are part of our bag of the words. Yeah, so when we say sparse vector, many of the times only this particular sequence vector is enough. Okay, but if we want to talk about document vector, then maybe this is our document vector, or this could be our document vector. Length of bag of the words or length of this present absent. So there is no fixed method as such to calculate bigrams. So bigrams is when we consider two words together. So there was this question in this particular assignment. Yeah, this particular question. So this you can say that it is bigram question. So bigram is when we want to consider frequency or probability of one word, then we are considering two words, the previous word as well. So went to. So when we want to calculate probability of the word to, we will also consider previous word which is went. So if we are considering these two words together, it becomes bigram. And if we want to consider three words together, then it will be trigram. 4 words, then quadgram, and so on. So n-gram. So what we are doing is we are considering this went to as one entity. And so what Markov consumption says that the probability of the current word, the probability of occurring of the current word is dependent on probability of the word which occurs before this. So for us current word is to. So which is the word which is occurring before this is went. So went is here. So what we will do is, how we will calculate is, we will count how many number of times the word went has occurred in these sentences. So 1, 2 and 3. So 3 times. And how many times this went to has occurred? Word to has occurred. 1 and 2, went to has occurred together twice. So this is 2. So gives us probability of 2 went, 2 went. Sorry, not 2 went to 2 went. So this is our final answer, 2 by 3. So these type of probability calculation questions will be asked. So all these questions, the probability questions, you just have to count how many times they have occurred. The definition of probability, how many times that condition has occurred, divided by total possibilities, number of possibilities. So went to, the possibility of 2 occurring after went is every time went has occurred. So how many times went has occurred? 3 times. Out of that, how many times went to has occurred? 2 times. So the answer is 2 by 3. So you don't even need to remember the concept of bigram, trigram, and so on. You just have to kind of apply probability. How many conditions are happening together, and how many conditions are total possible conditions, and how many are conditions which are asked. So that you need to remember. Quite easy to calculate, quite easy to remember. Please don't get confused. only the fancy names have been given, that Markov assumption, that probability of current word will always be dependent on probability of the previous word, or what is the previous word that will determine what is the next word, upcoming word. That is how we write English also, na? That is the rule of language, that many of the times many words, that is how our sentences are structured. There will be verb, there will be noun, there will be adverb, there will be pronouns. So all these, the sequence of these words is fixed in English language. So this what Markov assumption is, translation of that grammar rule into mathematics. When we apply English grammar to our language, there is a set of rules which we have to follow to write the sentence. So now that set of rules, Markov converted into probability. So this is what I did, Binduji. From this sentence, this is how we did. So from these sentences, what we will do is we will see how many two words together have occurred. So Sham went, has it occurred any more number of times? So no. So this bigram, Sham went, has occurred only once. So went to, how many times it has occurred? One times, and this two times. So went to has occurred twice. Then to the, how many times? Once. That's it. To the has occurred once. The football, how many times the football has occurred? Only once. So the football, only once. This is how we calculate. A Levenshtein distance is this thing, edit distance. Fancy name given to edit distance. This thing only. How many alphabets, how many letters we have to change to convert one word into another word. Yeah. So distance between words, how we are calculating is, we are calculating how many alphabets need to be changed, how many alphabets need to be replaced, and so on. Any more doubts? So Levenshtein is edit distance. So I have pinned one comment in the chat box for the Google Drive, where I upload all these PDFs, the presentations which we use, whatever rough work we do, all that marked, this thing I have pinned. I hope all of you can access to that link. Those who have joined later. So I will be putting today's PDF also in that folder. So the link I have shared belongs to the folder. So you will find from week 1 to week 10 all the PDFs you will find in that particular folder. So if you want to refer back how that particular numerical was solved in any week, or if for anything you want to refer it back, you have access to all the PDFs. So for edit distance, this is very simple example. What we have done is, we'll calculate how many letters need to be replaced. So in intention and intuition, these 3 letters are same here, and this last 4 letters are also same, right? Only these 2 letters need to be changed. So the minimum edit distance is 2. That's how we calculate edit distance, minimum edit distance. There was another example, affect, effect. Now you only tell me what is the minimum edit distance between these words. These letters are same. We will change only one letter. So what will be the edit distance? 1. So if we are done, we can close today's meeting if there are no more doubts. And we'll meet next week with week 11 assignment questions and content also. Okay. Okay, so I'm closing this meeting.
Thank you, ma'am.
Yeah, okay, great. See you next week. See you all next week. Try to join on time because in the beginning of the meeting, I try to cover the theory part of that particular week in short. So once we are into that zone of the theory, then for us solving and understanding the assignment questions is easier because I understand most of you are working professionals who don't get time to watch the videos every week. So what I do is I kind of compile all the theory points, important points, and we discuss those points before we dive into assignment questions. So if you are there, if you are present when we are discussing the theory part, then it is easier for you to understand what is happening, how the questions are getting solved, right? So since now I know that these are the names which attend every week, so every week only these people, most of the people are present today, they are very regular, they come every week. So if you join on time, then we will finish it early, we will be free for our other works also, and then we will get time to solve the doubts as well. So sometimes what happens is many of the times we are solving very trivial doubts, for about such doubts or such concepts we have already discussed during our theory discussion. So that's why we can devote that to actual problems or actual doubts, giving different examples and so on. So that's why it is request that please do come on 7 o'clock, because by rule I'm supposed to start bang on time at 7. Even if nobody joins, I'm supposed to start speaking alone in the meeting and start recording. Okay, so please, I'm like I at most I can wait is for 1 minute or 2 minutes for others to join. So if you are joining, because most of you guys who are present right now, you are the one who come every week. So for your benefit only, if you join some 5 minutes before, then you will have the complete picture of the session or the week, and then we can have discussion, one-on-one discussion. And I don't refrain, we have this, we are open for open discussion also. You can unmute and talk, ask questions. So even though I have put rules, but those rules are for larger classrooms when there are more than 20 people, 30 people, but mostly we are in terms of 12, 13, 15, that's the number of participants in online meeting. So we can have a discussion based classroom for this doubt solving session, where I'm not the only person who is talking, but you can also unmute and talk. I will be very happy if such talking happens. So if you can spare, or if you can manage proper internet connection and have a microphone enabled headphones with you, then I would be very happy if you are unmuting and talking, and if a short discussion happens for every doubt instead of talking in chat box, talking through chat box. I will be very happy if you are also unmuting and speaking. Okay, so this is one thing I wanted to convey, that please feel free to unmute and talk. we let us have discussion, let us make this discussion and not the one way problem solving. If it is discussion, then maybe you will remember these facts in your exam also, and you may score better. So that was one request. Okay, so and I'm saying this because you guys are very regular, all of you come every week. That's why this is the request from my side, that please be on time and feel free to unmute and talk. Okay, so see you all next week.
Thank you, ma'am.
Thank you, ma'am.
Yeah, thank you. I'm closing
Thank
this
you.
meeting now. Thank you.